For the system could be remotely allowing water to enter the pipe. It could be remotely controlled, typically for the manual release located at each hose level. So this one, it's allowing for remotely control and operational for the system. Advantage, doesn't require a pressurized air, so the operational and the cost and the maintenance is less. Another advantage is working remotely and could be suitable for the area where you have temperature is less than 40 degrees Fahrenheit. And it is common in industrial complex area or a public area where you have a temperature going less than 40 degrees Fahrenheit. But in all the systems, the pump room for the water, it has to be the temperature, it should be higher than 40 Fahrenheit degrees to allow the water and maintaining the water running from the pump up to the dry pump valve. Manual standpipe, which allow the water in the pipe at all the time, and the water typically supplied from the building domestic water system. And this one is applicable for a small dwelling unit. The pipe size not more than 3/4 inch or 1 inch in diameter. And it is usually required additional piping to provide adequate water pressure. It is common in the old, mid, and the high-rise building for residential and the dwelling units. Advantage for this one, it's working with water, with domestic water, depending on the pressure of the water itself. So it doesn't have a high commercial cost for the installation. And the small one, it is typical for what we talked about it last time for NFPA 13D for the dwelling unit upper. Last one for the manual dry standpipe. From the definition, it is dry pipe. The pipes are empty, doesn't have water, and the firefighter can connect the water supply. So doesn't have a pumping system. It's just dry pipe, empty dry pipe. In case of fire, connecting with the pressurized water from the fire truck itself. And the common in remote freestanding pipe structure, such as parking garage, which is commonly in area, freezing area, temperature is very less, and has a less risk and less priority for and hazard area for protection, which you can just, so we are allowing for this one in case of fire, manually firefighters coming to the building, connecting the water, start injecting, which is taking more and more time as well. But it's another type of the standpipe. The common use for our application, which you might find it in most of your project in your life, the wet standpipe. Even the manual standpipe could be applicable for the construction area as a temporary firefighting and the protection system inside the construction area, or you might connect it with a small pump for pressurized water. Both could be acceptable for the civil defense during construction. The classification for the standpipe system, it depends on the diameter of the outlets. And the 3 categories for it. Class 1, Class 2, and a Class 3. Difference between the classes is the pipe size itself and the amount of water. Class 1 is the biggest size. The diameter itself of the pipe, it is coming with 2.5 inch over 1 inch reducing cap. 1.5 inch is the diameter, for the outlet connected from the 2.5-inch pipes. Coming with a high pressure, directly connected for the standpipe vertically. And this one cannot be used by normal people or people not trained. Even one person might not be able to control the hose itself, and it required 2 or 3 persons to control it for the hose, for the pressure itself. It's 2.5 inch over 1.5 inch reducer. It's a huge amount of water. It's going outside. The application for it, for the high-rise building, for the open area, big areas which required a huge amount of the water for the fire suppression itself. Could be used on malls, open parking garage, underground building, high-rise building. It is coming with 2.5-inch angles and the reducer 1.5 inch. It's only to be used with the fireman department, and he's coming with the hose itself connected to the landing bar and start fighting the fire from this one. The valve itself could be used as a temper valve, which will be connected with the fire alarm control panel. So in case of fire, this one considered as a manual initiating device. In case of fire, it's opening, rotating, allowing the water to flow, and from this one, it is giving a signal for the fire alarm control panel and starting the fire mode scenarios as well. You are using? Second class 2 standpipe. Class 2 standpipe, it is coming within the hose rack, pre-connected with 1 inch or 1.5 inch hose. A smaller size with the hose nozzle. The water pressure and the volume requirements must be less demand. And this one, it's also for the fire department to use it, not for the normal people to start to connect it and utilize it. And it could be installed in hose or smaller cabinets. It is equipped with 1.5 inch with the hose length vary from 50 to 150 feet, 30 meters. It is designed to discharge water at 50 GPM per hose rack at 55 psi pressure. It's taking the capacity and the demand of the water for calculation 50 GPM at 65 psi. Normal question, it is coming from the civil defense. What is the class 1 standpipe definition for the class 2 standpipe? What is the differential of the diameter for standpipe? And asking you about the diameter, pressure, and GPM for the different classes, class 1, class 2. When you are making calculation for this one, for the fire pump, we are using the 50 GPM for the fire hose in case of a class 2. Class 3 is combined between class 1 and the class 2. It has 2 outlets, 2.5 inch and 1.5 inch outlets. Water and the pressure requirements same for the class 1. And the class 3 should be carefully considered. Safety and reliability concerns. Many authorities suggesting class 1 standpipe instead of class 2 or 3 because of the huge amount we can utilize it from the class 1 diameter. Class 3, it is coming with 2 outlets, one for 1.5 inch, another one for 2.5 inch outlets. And it can be connected, utilized from both. All the time for the installation and the inspection for the standpipe. 2.5 inch, it is normally closed, and 1.5 inch, it's normally open. In case of operational, you are pulling the hose itself, and it is automatically filling the water. You have to be careful when you are making after flushing, after maintenance, discharging, assuring that the valves are normally open. It's a part of the inspection for the continuous testing and the inspection for the standing pipe. Can we make it the standpipe separately for the class 1, class 2, class 3, or we can connect it with the sprinklers itself?
No,
different riser for sprinkler. What is the advantage and why you are taking this direction? Based on what? Is it required for the civil defense, required from NFPA, or design recommendation, or normal common practice, or
mostly common practice?
Okay. What is the advantage? What is the difference?
You can make wet and
most of them they are wet.
You can make one wet and dry.
What is the advantage to make it one wet and one dry?
Cheaper cost for the dry, just on capacity. For every wet riser, you have 52 kg and you keep adding this 59 kg. So they are dry riser.
What is the advantage to saving the what? Saving the sizing of the fire pump.
Yeah.
Fire pump, you are taking the consideration the remotest fire hose reel. Either it is dry or wet. You have to calculate the amount of discharge water. So the only difference is the water filling the pipe size itself. But sizing the pump, you have to consider as an operation. So it will not save the size of the pump.
It's one thing. Sizing the pump alone, wet standpipe is something else. For every wet riser, you add 50 kg.
Correct, but you have to consider when you are considering the pump size, you have to consider both. The pump, it is working for both.
You're saying both are wet, not one dry, one wet. Both are wet.
Yes.
Wet riser standpipe and sprinkler system.
Okay. When you are making sizing calculation for the pump, you are considering the sprinkler is working and the hose as well, the standpipe as well, it is working. Not one and one. So considering both for the sizing calculation of the pump. Pump sizing calculation, you're taking 3 scenarios. The remotest sprinkler, the most demand, and the standpipe. So you are calculating all of them and taking into consideration the highest demand. So the sizing of the pump doesn't make a difference if I make stand alone or mix it. As a sizing for the pump, or even sizing calculation for the tank. The tank size, it will remain the same.
The pipe size.
Pipe size would be the same. You are taking the scenarios for all, the 3 scenarios. So to size the pipe, so it will not.
Landing valve separate.
So you have 2 pipes?
Yeah, you have 2 risers.
Okay. The pump size.
Not pump.
The pipe. Okay. But by this case, you are running 2 steel pipes. Commercially, it is costly. For the high-rise building, if you have 20, 30 floors or 15 floors even, I'm running 2 pipes vertically with the valves, with the accessories, etc. Is it costly or the same expense?
It's costly. Of course.
It's costly. QCDD or NFPA doesn't asking for to make a split or combine. It's a design parameter. It's value engineering. or decision to make it advantage and disadvantage, which one is suitable for you. If you have a standpipe and vertical riser alone on the staircase away from protected area of the sprinklers, so I have to make it one separate and one. You don't have a choice. But if you can combine both together, it's better for me to combine both, saving the pipe size, the pipe expense, and the valves and the accessories and. What shall I do? Correct? So this is advantage and disadvantage. NFPA or QCDD doesn't have restriction or pushing you which one to use. Design parameters. You decided. And even in many cases, the design, it comes for me for the IFC drawings from the tender, from the consultant. It is two pipes system. During construction, I submit it and make a calculation, etc., and submit and start applying combined system with cost to impact or value engineering, whatever it is. It changes the system, saving the time and the time cost for installation, maintenance, accessories, etc. Commercially, if it is required, if it is applicable, it's not mandatory. So why shall I go and wasting the money for the pipe for no use? So you can combine the both together the same. Okay. The water pressure and the flow requirements, it is depending water pressure, it is depending on the most remote area. You have to calculate it, and calculating the pressure, the vertical height of the building, and the static pressure for the pump. Okay. In our civil defense, if you notice here, we are not talking about any design calculation or sizing. What is the size of the pump itself? We are talking about the valve and GPM. We are not talking about the sizing of the pipe itself. We did not talk about it. What is the pressure? We are not talking about the sizing calculations, etc. What will be the operational pressure for the water? What is the sizing for the pump? Sizing for the tank? All of these design calculations is not part of the exam. As you said, the exam, they are asking about your understanding about the system, how it is working, what is the main concept for this one. But making a design, you are contractor. You might not have a background for the calculation of the sizing calculation for the equipment, and it is not required for the civil defense. You might be working for the maintenance. You don't have the background or capability for the design parameters. It is not required. But civil defense, they are asking about the main concept for this one. Okay. Okay. How it could be reflected in our exam? When they are asking about make a single line diagram, schematic diagram for the fire fighting system for ground for a building J plus 15 plus 2 percent, you have to show for him the components of the system itself. We started from NFPA 13, the sprinkler types, and the coverage of the sprinkler. Show him the distance between the sprinklers itself, giving a number for each sprinkler, which will have to be reflected on the drawings as well. When we would go for the details of the level of details for the drawing, for the submission, for the civil defense approval, design, or as built, even, I have to show tag number for the sprinklers reflected on the schematic diagram.
You will ask also for the distance of the schematic.
You can make it a distance in the schematic. If he give you a classification for ordinary or low hazard or high hazard, you can make it. You can make a distance. The more information you show it, the more confidence you give it for the person who is reviewing your answers to get confident that you understand. Showing the number of the sprinklers. You don't need to show if the floor it is covered by 50 sprinklers. You don't need to draft 50 sprinklers. Sprinkler 1, 2, 3, up to 50, for example. Showing the drain point for the sprinkler. Showing the standpipe, combined standpipe with pressure relief valves. showing the fire hose cap identification. So you give him the feeling that you understand what is the components for the sprinkler system, flow switch, zone control valves, vertically the standpipes. The diameter you can show it 5 diameter or 500 or 550 to give him indication that such a design parameter should be indicated on the diagram. Showing the fire hose cabinet, class 1, class 2, class 3, classified for. The more information you give it, the more confidence you present it for the reviewer about your understanding about this.
And this is only one question of the exam of this.
Only one question. 90% it is coming for within the question, the exam. 10% some people they are not getting the question. Very few, but normally it is coming. Asking about the schematic diagram for warehouse, for storage area, for residential building, for hotel. Doesn't matter what is the natural of the building. The interest for the question is not the natural of the building, what I have to show. The interest to show him the component within the schematic diagram, what you have to reflect. Natural of the building would be number of the sprinkler, how many floors, doesn't matter, but it is repeated every floor. And this horizontally, it is repeated. Fire hose cabinet, it is repeated. Landing valve, it is repeated for each floor. So you need to see your understanding about the system components, which will be developed during design or construction or maintenance, operational, testing, etc. You know what is that. Okay. Going down to the fire pump, diesel, electrical, jockey pump, the common header, and the tank. Okay, for the suction and the discharge lines, this is a part of what we have to show it and present.
Okay. You mentioned the capacity of the tanks, or say just 60 minutes non-stop.
Two compartment tank, sizing of the tank, how many gallons, how many square cubic meter is not the question. Again, they are not asking you to size the tank. Or even the pump size. Shall I show it 1000 GPM with a header of 15 part? It's not required. Okay. But can I show it's a electrical pump and a diesel pump? It's better. Jockey pump, it's mandatory, you have to show. And is it electrical or electrical and the standpipe, electrical, 2 electrical, or 1 electrical, 1 diesel? It's good to show that I know what is a component. Jockey pump, it's mandatory. Okay. And so on. Minimum pressure and maximum pressure for the classes. For the 2.5 inch, it has to be 100 psi. For the 1.5 inch, it has to be 65 psi as well. So type group 3, which is combined. What is the pressure for group 3?
100 psi.
100 psi with pressure reducer for the second one, which will, it is coming with the connection of the valve with built-in pressure reducers. Okay. When I'm connecting the standpipe with the 100 psi to the sprinkler, pressure reducers as well to maintain the operational of the sprinklers. Okay.
The sprinkler, but the pressure reducing with 100 psi.
With the pressure reducers.
The sprinkler can go up 12 bars from 8 to 12, and 100 psi is around 8 bars. Why would you pressure reduce? If
you have with 100 psi, you might not need it, but if the pressure is going higher, you have to, depending on the height of the building and the pressure. Okay. Okay. Minimum flow requirement. Just giving you the figures, which I make it with the color to bring to your attention. This is the numbers that might come in for the question within the exam what is the minimum flow requirements for group 1, group 2, group 3, etc. For group 1 and 3, it's a minimum 500 GPM flow rate, in addition to 50 GPM for the standpipe. So I'm talking about 500, 500, 1000 plus 100, 250. Its total should not exceeding 1250 GPM for the class 1 and the class 3. Okay. When a building equipped with a sprinkler system, requirements reduced to 1000 GPM. For the class 2, which is a small 1.5 inch, it is taken 100 GPM flow rate as well. So the questions it might come: the flow rate for the class 1, the operational pressure for the operational for class 1, class 2. What is the flow rate, minimum flow rate required? Just asking about the figure. Which will be considered for the sizing of the pumps, but pump size calculation is not required. Okay, it's not required in the exam, but when we come for submission for the civil defense, we'll go in details for the calculation. And even civil defense, they have the minimum requirements to show it in the pump size calculation report itself, even within the design or within the as-built. It's around 15-20 requisites for the calculation to be presented within the submitted itself. It's not part of the exam, but as I'm saying, I will give it for you in addition to the exam requirements, for your knowledge and for your experience when you are preparing any submitted for the civil defense. Any design, what will be the minimum requirements, how to prepare it. In the as-built, what is the minimum requirements, what is the additional details and the information you have to present it higher than the design calculation. Yeah. Another component for the standpipe, the main one, connected to the fire department connection, which we call it Siamese connection, breaching outlet for fire department connection. What is the purpose for the fire department connection? From the definition, connection provided for the fire department. What is the purpose?
In case of fire, to bring over the engine, fire engine, inside the building. In case of the pump that didn't start.
Exactly. In case of failure of the pump or long time for the firefighting and the tank it becomes empty, pressure it becomes low, you are connecting for the fire truck, connected to the fire department connection and start injecting water inside the pump. A side question, what is the maximum pressure coming from the fire truck? Not in the exam, just fresh.
160.
65, sorry.
7.5 bar is the maximum pressure from the fire truck. I think the maximum size here they are using, they have 2 different sizes or 3 different sizes of the trucks within the civil defense. The maximum pressure they have it for the operation of the trucks, 7.5 bar is the maximum.
And this is not enough for the recovery on the building.
Yes, if you have a high-rise building, it will not be pressurizing for all, but this is the maximum they have. So in this case, they have to use the boom to reach the highest in the building. That's why in the fire department connection, you don't need to go for higher than 7.5 bar or 8 bar maximum pressure for the selection for the fire department connection. Even you have the operating the system for the network higher than. And it was one of my cases, the operating pressure from the network, 8 bar or something for the high-rise building. Fire department connection, it's only connected for the fire truck. It's a bar. Doesn't have any operational or any function within the network itself. So just to connect it to withstand the pressure coming from the fire truck. The maximum pressure is required is 7.5 bar. You don't need to go for higher rating of the selection. Cost-wise, you don't need it. It is available, but you don't need it. Okay. Fire department connection installation, it could be installed as a part from the external wall of the building, subject to have 10-meter distance maximum from the fire standpipe to reach the fire department connection. And this is as per the QCDD requirements, you have 10 meters maximum to reach. If the building it is set back away from the fire stand by long distance, you extend the fire department connection, and it could be standing or freestanding on the. Okay. What's the difference between the fire department connection and the fire hydrant?
Fire hydrant can take water.
Fire hydrant and the fire hose cabinet, or fire landing valve or hose cabinet. Those are the same function. You are taking water from it. This one for the outside yard, and the other fire hose cabinet inside the building. Both you are taking water. Fire department connection, you are injecting water. The pipe material could be ductile iron, cast iron, malleable iron, steel, or copper, depending on the operational pressure you are setting. All of these types of the pipes, it's applicable for the standing pipe. We are using here commonly. Exactly. Most of them, they are working because of the pressure and certified from the civil defense. But as an FDA, they are accepted for the copper or for the steel as well. Even for the NFPA certificate for dueling unit, they are accepting topics as well for the network. Topics PVC, UPVC pipes. UPVC for the standpipe, for the network piping of the dueling unit, and small dual unit, 1 or 2 family units. And they are working on easily have it with connected with a domestic water network, or you have a small pipe. This one especially for the dueling unit NFPA 13D, which we talked about last time. The gauge, the pressure gauge, another component within the standpipe itself. The function for pressure measurement of the network. Location for the gauge, where you have to go.
Alarm check valve, pump control valve. Alarm check valve, pump control valve.
This is about we are talking about the gauge for the pressure gauge.
The gauge for the pump control valve.
Okay.
The alarm check valve.
Okay.
The pumps.
Common question: calibration for the gauges and the meters should not exceeding more than 6 months. 1 year should be calibrated.
1 year.
Not more than 1 year. The 6 months, you know what is coming, the number of 6 months. Validity for the test should not exceed more than 6 months. What does it mean? If you complete the installation and you are ready for the civil defense inspection, you have to make completion test and handing over for the system and the pressurized, and after the flushing, the pressure and completion test for the building. The validity for this test should not exceed a time 6 months before you submit it for the civil defense. If you are submitting after a period 6 months from the test time, civil defense will reject it. You have to renew it again. The gauge itself to determine the water pressure within the network and measuring the operational pressure, assuring that the operational pressure for the network as per the rated system operation requirements should be subject to freezing temperature as well, should have a control valve capable for a drain. It is required at the top of each standpipe to assuring that pressure at the farthest point is sustained. Recommended on each side of the pressure regulating devices. The valves we are installing on the standpipe. It has many types of the valve. Let us talk about one by one what is the functional for these valves. A check valve installed between the fire department connection and the standpipe system. The functional to prevent water to flow back to the fire department connection. So it is allowing for one direction of the water. Could be questions as well. A valve is used for preventing a flow back of water for the department connection. A valve connected between fire department connection and the standpipe. Okay. What is the definition of the check valve? Many questions can come from this point. What they are asking for, to understand what is the functional, what is the operational, what is the position, what is the type of valve we are using. Control valve to permit water to flow into or through the system when it is open. What is the functional for the control valve? Isolation pump. Required for maintenance purpose of the network. Drain valve to drain the water from the network for the maintenance purpose, etc. For the testing of the The hose valve, which is connected to the fire hose, pressure restricting or pressure reducing valve, which is reducing the pressure from different network areas. It is required extra care and attention for the operational flow test, and the time acceptance is the curricular. Fire companies and inspectors conducted required a testing for the pressure reducers valve to assuring that the operational valve and reducing the valve. By the way, let us talk about the test. The test for all of the components. As a civil defense requirement, all of these components should be pre-approved for the civil defense before you go for any installation. So for any system, you have it for the life safety and the firefighting system. All of the components, you have to submit it for the civil defense approval. You cannot install unless you have certificates from the civil defense for the manufacturer and the model and the country of origin for each type. It has to be maintained.
That will be referred to some other certification, like Gateway, like Mark or UL.
The certification, it is for the manufacturer. It doesn't release the approval from the civil defense here. And civil defense might require the pump to be UL and FM. You cannot get any pump from manufacturer, not UL FM, and submit it for the civil defense approval. It will be automatically rejected. But civil defense, they are testing and certifying and checking the test submitted and the sizing of the pump, the temperature, the operation, etc., according to the catalogs and the data sheets and the certificates you have it, so we can approve the pump itself to be certified or accepted from the civil defense. So first, it has to be accepted from the civil defense. However, when you are submitting for the civil defense, or for example for the fire pump, you have to make a factory test for all the pumps, getting certified and witnessed from the factory, and providing the test result for each pump. Submitting for the civil defense, in addition to the site acceptance test, certified by third party and witnessed by certified QCD engineer, and submit for the civil defense inspection request. So all of this documentation and the procedures and the certificates and the test result, you have to collect it for the submission itself. What does it mean? We are contractors. When I'm working on site, whatever material I'm procuring for NAFCO, for other companies, assuring that the material is certified, accepted by the civil defense. Number one, providing data sheets. You prepare your submittal. I'm targeting for the submission for the inspection of civil defense after 1 year. Starting from today, I'm compiling and collecting all the documentation one by one. Data sheets, test certificates from the civil defense, etc. Compile the documentation. When you are coming for the submission, it's a long story to compile everything, and you might miss some of the components, some equipment, and you submit it will be rejected because of missing components like landing valve. We did not submit the test certificates and the data sheets, and they will reject your submittal. I have to tell you. Not only this one. When civil defenses are coming for inspection, you have to prepare a sample room. Sample room like this one, gathering all the drawing for the firefighting system, the approved drawing for the inspection, printing one set A1 size at least, fire alarm, life safety plan, firefighting, emergency lighting, collected one set of all, in addition to the site plan and the evacuation maps. Copy of the material submitted for all life safety devices, for all of your components, including the data sheets, including the QCD certificates. So we have to make one set, fire pump, material submitted, data sheets, certificates, test report, factory test, etc. One bunch. Landing valve, fire hose cabinet, fire department connection, sets. You have to compile. Okay. In addition to a physical sample, whatever is applicable within the project. بتجهز دلوقتي بيجهز السبميتال.
ده كلام مشاريع مشروعين ثلاثه ميجا بروجكتس ميجا talking about 60 buildings. يمكن تعمل 60 buildings. 60
buildings 60
مبنى.
high rise building?
No.
Medium rise. مفيش high rise building.
مثلا G+1, G+2, but it's a small different function, different application, pump system, different from with respective systems.
Exactly. You prepared yourself, or you hire someone to do?
We do everything.
A separate department for civil defense submission.
Basically, the whole department will work for the civil defense.
Finally, if the mood of the inspector is not good, he will come for 1 minute and he will reject everything. One paper is missing. Where is that one?
والله كان من على الباب. كان من على الباب والله. من على الباب.
والله لانه بيجي هو جاي بضيوفهم. يقول حتى بالسياره بيحكي بالبيت.
الله المستعان.
اول مره راح بالسياره رجع على السياره.
Let us continue for the ones. Continuation for the valve, the hose valve, fire hose. I think we talk about this one. Hose cabinet. The cabinets for the fire hose cabinet and the fire racks and nozzle. The cabinet itself, it's an enclosure to contain the hose and the racks and the nozzles. The cabinet door might be locked itself. The size of the size of the cabinet itself, it has to be sized to contain the racks, fire extinguisher, the hose. It would be one compartment or two compartments, depending on the distribution. You have a type 1, class 1 or class 3. What you are putting extinguishers inside or extinguishers outside, etc. The door itself could be, the cabinet could be recessed, could be exposed. Civil defense doesn't have any restriction for this one. The door itself could be replaced with a decorative door. If it is recessed and they have a decorative door in the front, it is acceptable. You could be replaced the door itself of the cabinet. If you have double doors, they have to be linked together. Architect decorative doors and the cabinet door itself linked with a bar. So whenever you are opening the architect door or decorative door, it is automatically open the cabinet. The cabinet doors itself, it has to open 100 degrees to allow for the hose without any obstruction, allowing to put the hose completely outside without any obstruction. 180. 180 is sometimes not acceptable. 90 is not acceptable. Not acceptable. It has to be 180 to allow for the hose. If it is 90, you cannot take the hose for the other side.
We can order left or right. We can order the door to be left or right.
Right, but if it is 90 degrees, it is taking the distance.
If you're starting from the beginning
of corridor,
let's say, and you're running only this way.
Okay, so this is fine. Yeah. If it is in the corridor,
it's not in the middle. As long as it's not
yes,
in the middle.
yes. Maybe I'm in my head, it's in the middle of the corridor. But if it is in the corner of the stair, doesn't make a difference. Doesn't make a sense. It is 90 degrees. Okay. By the way, all the cabinets should be marked physically on site. You have to install the sticker for the fire hose cabinet, giving indication, giving a print out, signage for this one. Not only for the stickers or the sign or the marking, you have to add emergency light on the top, very close to this area. So in case of fire, emergency light, it can give you a direction where the equipment is at. Okay. The hose itself, assure every 1.5 inch or smaller hose outlets used is equipped within the cabinet. In extremely cold climate, it hose might be stored in another location to avoid any freezing for the water and the damaging for the hose itself. The hose itself, you have to maintain it and the testing frequently to assuring that there is no damage, there is no cracks, there is no leakage within the hose. The nozzles, different types of the nozzle would be equipped within the fire hose cabinet. Could be with handles, depending on the diameter and the type. And then the hose itself, it has to be operated directly within the water when the water is started, so it has to be without any lock, releasing the water direct. Equipment within the fire hose cabinet for the reel, for the hose, for the reels, for the extinguisher, depending on the design parameters, the amount of water is required. The hose itself could be within the cabinet itself or could be stored away. One of the tests of the cabinet civil defenses are one of the tests for the civil defense, and sometimes it is coming as a comment. Opening the door and closing, open, close, to assuring taking the reel outside, putting it inside again, taken out and in, to assure the mechanism of the reel itself is standing as a mechanical fixation and robust to carry the load and opening. Okay. Sometimes during the test, it's coming that taking the reel outside 1-2 times, closing the door it is not locking correctly. It was one of the comments to fix it.
Regarding the pressure restricting pipe, is the defense required us to remove the handle to be a type lock sheet type pipe?
Which one?
For the pressure restricting pipe.
Okay,
They ask you to remove the handle, so no one will tamper with it.
definitely.
You have to remove.
You have to remove it. Although it is not accessible for the public, for the common people, etc., but for the protection, they will ask you to remove it to assure that there is no one will touch it. Protection for the standpipes itself, if it is in an area accessible for the public or subject to mechanical damage or some mechanical hitting for the pipe itself, you might make a protection around the with some guide rails or some this one. Normal cases, it is not required because it's in the back of the house, in the stair, in the back of house stairs for the services stairs, so it is not subject to for the public. So and mechanical damage or risk, it's not that happening. Right. So the kind of the questions for this one, I think we covered for the first one about the definition, about the applications, about the use, the pressure, the GPM, the flow, etc. The types. We covered all of this one. Second part of the exam, it is coming for testing and the commissioning and the maintenance. For all sections of NFPA, you have the first part for the chapter, it is general, introduction, definitions, and after that talk about the systems of components itself. For the sprinkler types, etc., for the standpipes, for the components, for the valves, for the operational and the categories, for the selection, for the sizing, and. Last part of the NFPA within the section, it will be covered by testing, inspection, and maintenance. I think I shared with you last time for the testing and maintenance chapters, which is collecting from the NFPA different sections what is acceptable defense they are looking for. Okay. And when civil defense in the exam they are asking, you have to follow and answer as per the civil defense. 95% or 98% they are matching with the NFPA. If there is a difference, you have to answer as per the QCDD. Okay. So what you need to do, go through this manual of testing commissioning, not only for the exam, but for your maintenance and operational as well, testing and inspection, periodical test and maintenance. You should know what is going on. For the exam, we have the NFPA. We explain it here. Whatever you have a difference, highlight. In case for the exam, you have to answer according to the civil defense itself, not according to the NFPA if there is a difference. For example, NFPA, they are asking for testing every 6 months for one item. Civil defense, every 1 year is okay. Answer it according to civil defense. It's very few areas where they have. First of all, for the system, it has to go and passing through the acceptance test, which is a test after you complete the installation, before you go for civil defense inspection and the handing over for the system. Definitely before the system testing, you have to make a flushing for the full system. Third party should be witness the test of the systems itself, and the certified should be signed as well from the certified civil defense engineers. Acceptance test for the standpipe for the class 2 and the class 3 systems installed should be included yard piping for hydrostatically testing for the period of at least 2 hours and not less than 200 psi. For the class 1, class 2, and the class 3, the operating pressure for, it will be 100 psi. Testing, it has to be withstanding 200 psi for the period of 2 hours, or 50 psi at least, exceeding the normal operational pressure, whatever it is greater. So if it is 150, it has to be 200 psi. 170 psi operation plus 50, 220. 120 psi plus 50, 160. I have to test it at 200 psi for a duration of 2 hours. Pressure in the network for 200 psi for 2 hours operation. This is for the test itself. The hose on the standpipe can be hydrostatic test for 2 hours before placing on the surface for the acceptance test for 2 hours with PSI. The pressure should be maintained at least for 15 seconds and not more than 1 minute, during which time the hose shall be not be leaking, nor shall be a jag serrated break during the test. Hydrostatic and air test. Hydrostatic test, we said it's minimum applying a pressure test for 200 psi for minimum 2 hours. Or you can apply it for a 24-hour air test required for the dry pipe system. Applying for 40 psi air pressure for 20-hour 5 period. So for the dry pipe system, tested by air, 40 psi continuously for 24 hours. Wet pipe system, 200 psi for continuously 2 hours. This is also part of the question of the testing acceptance test for the duration. What is the pressure time? 50 plus 150 or 200, whatever is greater, duration for the 2 hour. For the air pipe, 40 psi for duration of 24 hours. Visual inspection for testing, for inspecting the system. Systems is pipes. So checking visually for the crack, for the leakage, if any component is not corrected, the pressure and the selection for the equipment, it is properly matching with the design parameters for the operational pressure for the network, etc. Flushing system, before we make the conducting the acceptance test, make a flushing for the full network itself, and it has to be with a rate of 10 feet per second is recommended, and you can make a flushing and circulating for the water till you have a clear water as a sample test. Flushing for the system, depending on your system configuration, you might have flushing for the system in stage. Whatever you completed floor-wise, making a flushing and close the valves, complete one floor, second, etc. Flushing all the systems, flushing the standpipe, and flushing the network one more time. It depends on the configuration for the network and your testing and the commissioning strategy. For flushing and testing commissioning, you have to recommend it to have testing and commissioning agent from day one. Don't wait for the last stage to conduct testing commissioning agent who will be certifying and witnessing your testing plans. Many of the time when they are coming late, they are asking for additional valve bypassing. You have to make it additional inspection panels and the access panel for the ceiling, etc. It's costly and the time constraint. Better to engage them from the early stage of the project, at least to verify the design drawing, the shop drawing from the testing and commissioning point of view. Don't wait for the last stage. Flow test for the network, allowing the water to flow and determine the flow rate and the pressure available. Taking a place on the roof of the building, allowing the network to work with the full capacity and with the full discharge rate for the pipe. Checking the pressure, checking the water flow. It will be part as well from the testing for the fire pump network. Main drain test. Removing the purpose for this one for the maintenance purpose of the network. Removing the water from the network completely and the drain. Drain valve should be installed or installing a drain pipe next to the drain valve. The main drain valve should be fully open and display system gauge display static and residual pressure. Drain should be piped at exterior locations as well of the building and recommended to have a drain pipe connected to the sewage network to take the amount of water from the drain network. Operation of the component. Any component capable for movement requiring testing under operating conditions. For the standpipe, you don't have any movement component, but you have to conduct a hydrostatic pressure calculation for structure withstanding for the pipe itself, depending on the diameter of the pipe and the flow rate. You might install it rust blocks. You might install it cyanide, seismic connections, depending on the zones. I think here in Qatar we are not using the seismic connection for most of the building. We're Qatar almost in zone 2 for the seismic zone, so it is not required. If you have joint, depending on the building itself, you have flexible joints. You can install. Periodical inspection and maintenance for the system. Visual inspection can be taken care and the hydraulic test to determine the test pressuring for the test for the hydraulic test for the systems itself. Impairment. Some impairments are system related, some are not. Important for the fire companies to frequently tour their first due areas to avoid to assuring that there is no impairment for the accessing for the equipment itself. Maintenance purpose for the standpipe. There is no maintenance required as procedures for the standpipe itself, except for the visual inspection and assuring there is no rust, there is no leakage, or all the valves are open and properly operated. We can say that the maintenance, periodical maintenance and the inspection for the standpipe, it's almost nil. The only important issue for the standpipe is the acceptance test and the operational hydrostatic pressure test will be applied. Okay. This is the most important and the common question is coming from the circuit. Maintenance for the hose. Periodically test the hose annually, every 1 year, assuring that the equipment of the hose is in place, is available, there is no rust, there is no crack, there is no damage. Easily to put the hose itself outside and easily to maintain. Once it is pulled, it will be the water, it will come in Assuring for the connection there is no rust, there is no damage for the connection. For example, for the fire department connection, assuring there is no damage, there is no cracks, there is no rusting. موجود في البلد كنترول في الغرفه اللي جنب على طول.
ما دخلت انا سحبت
Testing for the hose, annually tested for physical test and operational for the hose. For the rack itself, it is easily to pull out. There is no damage, no cracks, no holes for it. It has to be tested annually. Most of the cases for the civil defense, if you don't remember the inspection and the test, 90% of the systems within the firefighting inspection semi-annually and the testing annually. For the fire alarm and the electronic systems, it might go for testing every 6 months for the detector, for the control panel. But for the firefighting, if you open the manual from the civil defense for the test, inspection semi-annually and the testing on annual. Within the exam, if you have a question and you don't remember exactly the answers, take it as a 90% semi-annual for inspection and annually for test. Continue for inspection for the system, checking for any defect for the hose itself, pressurizing the network, and testing for any cracks, for any damaging with the hose, and it has to be replaced immediately. I think this is all what we needed to talk about the standpipe as a system, pipes, +1, +2, pressure, etc., and the testing application. Okay. Any question for NFPA 14? Any questions, Sanita? Santos?
Question. I have 3 minutes only. You said each question like 3 minutes.
Almost, yes.
How many questions are there?
25 questions. 1.5 hours. 1.5 hours and 70% the passing record.
Like UPDA.
Almost, yes. But the difference from UPDA question, it is not straightforward in the most of the cases. It is tricky. QCD, straightforward. There is no tricks around. There is no way. What is the NFPA for the sprinkler? What is the definition for the fire department connection? What is the standard for +1 fire hose, standing pipes? Straightforward. It's open book. It's open book. You will get the NFPA sections on the screen, but it is not searchable. You cannot. Would you like to have 10 minutes break before we go for NFPA 20 for the fire pump? Let us have 10 minutes break and we'll come back.
راس العمل
لا
في وانا محمد بن
مو سالس لا إيه إذا نزل عليه شكل في بعد سوبر بسيط عندهم بقى سوبر بسيط سوبر بسيط لأنه أبدا أنا كل ما دي يعني
وعلى فكره انت بتبتدي فيه
حتى ما لا طبعا
انا بتوقع
أنا مش عارف كيف أتوقع هذا الكلام لا يوم ما أعرف بإيه
سوبر برازيل
أنا بحب سوبر برازيل أنا مش هو الأزواج
انا عملت لا طيب هذا ليس ما فيه كأنك تعطيها الآن
ماشي